So how do you make an array in a context where you're supposed to be immutable? So if you're being immutable, you can't mutate state, you have to return new state. So if you're adding a new element to an array, you have to make a new array with all the previous stuff in it, plus your new element, right? Which obviously if you're adding thousands of elements becomes quite inefficient quite quickly. One of the ways this was solved was in Scala. They have a thing called a vector. I don't believe it's used anymore, I think they've moved on to something else, but super useful, super interesting data structure. So what it is, a vector is a 32 element array if it is less than 32 elements. So you have to do that copying thing. But if you go over 32 elements, it transforms from being a 32 element array to a 32 element array of 32 element arrays. So you have this very shallow tree structure going on. And so when you add a new element, you're always adding it to an array in the leaf, the furthest leaf of this thing, but all the other arrays that haven't been changed by your adding of an element, they stay the same. And so you can just point to them. And so you don't have to copy thousands of elements, thousands of element arrays to create a new array. You just kind of create a couple of 32 element arrays and then point to the rest of the things that haven't changed. And so that's how they solved it. And I find this is a super interesting data structure because if no one has heard of this, or very few people have heard of it, so you can bring it up in things like interviews, when you're interviewing candidates, and have a really interesting conversation about things like recursion. Why did they pick 32 element arrays? What's the big O of getting something out of this thing, adding something to this thing? Why did they use it in an immutable context? It's a really interesting data structure to talk about. So there we go. That's how Scala solved this 32 element array situation. Cheers.